Hi friends, welcome back to new session. In this session, we'll see some objective questions based on a DC motor and a DC generators. Okay. See, first of all, before starting objective questions, so let us see speed regulation. I think this topic already indirectly I told you in the last video. Let us see. Tell me what is the formula of percentage speed regulation? This is a percentage speed regulation. Percentage speed regulation. If that color is not visible, I'm just writing with the yellow color. Percentage speed regulation is equals to what? No load speed minus full load speed by full load speed into 100. Okay, right. And this is for speed regulation of a shunt motor is positive because already if you see N versus IA graph for shunt motor, then you can understand clearly from no load to full load speed is reducing. So no load minus full load means you'll get positive value. Its value will be around 10 to 15%. And speed regulation of series motor is a positive, that to infinite percent. What is the reason? So what is the no load speed of series motor? It's infinite, no? So in no load, if you see this formula, no load speed is infinite. Infinite minus some value by some value into 100. That gives you once again infinite percent only. So I'm saying there is lot of there is lot of change in speed from no load to full load. Sorry, there a lot of change in speed from no load to full load. That's why series motor is having poorest speed regulation. It is having highest speed regulation value means it's nothing but poorest speed regulation I can say. Okay, and what about speed regulation of cumulative compound motor? You tell me first of all, as load increases, what will happen to speed will be reduces. Once I will be having positive and value will be around 20-25%. And let me take speed regulation of a differential compound motor. I told you already as speed, as load increases, your speed is increasing for differential compound motor. Please try to refer N watts IA graph for differential compound motor. So you'll be getting a negative value. Okay, no doubt at IA rate value, at full load condition, speed regulation of differential compound motor is 0. That is okay. But at IA rate means it's a 0 only. But here he has given this value other than at higher rate value. So speed regulation of differential compound motor generally it will be negative, so minus 5%. So whereas speed regulation of differential compound motor at higher rate value or I can say at full load condition is 0%. Okay, right. Let us see absolute questions regarding DC motor and DC generators. First question. So see, the direction of rotation of shunt motor can be reversed either by changing field terminals or by changing armature terminals, but not both. This thing I already explained. If you want, I'll show you. Let me take a D shunt motor. So armature and having shunt field winding in shunt or in parallel with armature, or I can see in parallel with supply plus minus V. Nothing but IL value, IA, and I can write here ISH value. And field wind terminals, let me take it as F, FF, and armature terminals, let me take it as A. So guys, try to understand. Suppose you know formula T proportional electrometer proportional to flux into IA. This flux depending on I can say ISH value. So if you want to reverse the direction of rotation of shunt motor, that can be possible by reversing a shunt current or armature current, but not both. That means shunt current reversing means what? It is possible by changing field wind terminals. IA reversing means what? It is possible by changing armature terminals. That means so if you suppose initial let me take torque is positive. If you make flux negative by reversing field wind terminals by keeping armature terminals as it is, so this becomes negative, so it will reverse. Or if you change, I can say if you change I mean armature terminals, it becomes negative here. Without disturbing field wind terminals, it becomes positive only. Once again, you'll be getting negative here. So torque will be negative. I mean direction of rotation of shunt motor can be reversed either by changing field terminals or armature terminals, but not both. So guys, tell me what will happen if you reverse both armature terminals and field terminals. It's a common sense. You please tell me. If you reverse both flux and IA, means if it is negative and if it is also negative, so what will happen? Torque will becomes positive. No? That means I mean direction of rotation of a shunt motor I mean will not reverse. Okay. So guys, try to understand that can the direction of rotation of shunt motor can be reversed either by changing field terminals or by changing armature terminals, but not both. So try to remember. And tell me, suppose what will happen for a shunt motor if the supply terminals of D shunt motor reversed? So then tell me, what is there any change in direction of rotation? So your answer is no. What is the reason? So let me take example. Let me take a simple example here. So what he's saying, if the supply terminals of this D shunt motor reversed, initially let us assume that torque is the positive. Initially, let us assume that I can say torque is positive. Suppose, so I can say Tm proportional to pi into Ia. So let me take flux positive, Ia also positive, and the torque will be positive. This is positive. This is what? This corresponds to this direction of ISH. The flux is positive. Corresponding to this direction of Ia, your Ia is positive, so torque is positive here. Suppose you, please tell me guys, if a supply terminal is reversed, that means instead of plus here, if you take minus, and if you instead of minus, if you take plus here. So now tell me, so already now instead of a current IL direction here, so current will be always, you know, it will start from positive terminal, no? Current flows from positive to negative. So here positive is this terminal, so current starts from here. So now please try to understand, this is what I can say ISH, and this is what I can say IA value. So try to understand here, initial IA is downwards here, now it is upwards. So that means here IA is what I can say, IA is reversing, no, IA becomes a negative, and ISH previously it is entering at F, now it is entering at FF. So obviously ISH direction also reverses, I can say flux also reverses, so flux becomes negative. So yeah, flux is becoming negative, IA also becoming negative, torque becomes once again positive. So tell me guys, is there any change in direction of rotation of shunt motor by changing supply terminals? No. So because if you are changing supply terminals indirectly, your armature current is reversing and flux also reversing. Nothing but shunt field current is reversing. So obviously your rotation will not reverse. So there is no change in direction of rotation. So please try to understand, if the supply terminals of this shunt motor reversed, then no change in the direction of rotation. Okay. So this is one more point. And please let us see this question. A D shunt motor is there running at rated speed. Okay, it is running at rated speed. Now my question here is, if the field winding is open, what will happen? So example, let me take a D shunt motor like this. So DC shunt motor. So having a field winding in shunt or in parallel with armature. And here I can say plus minus supply voltage V, or IL will be like this, IA will be like this, ISH will be like this. Okay. And is what I can say RSS, shunt field winding resistance. Okay. So here my question is, initially is running at rated speed. So please tell me guys, N proportional to I can say EB by pi. So initially it is running at rated speed, means initially some flux is there, everything is okay. Now what I'm asking here, if the field winding is open circuited, that means if it is open. So if it is open guys, if a field winding is open, so what about ISH current? Field winding open means what will happen to ISH? It will become zero, no? Flux becomes zero. So whenever flux becomes zero, what will happen to your N value? It will become infinite, no? So please, now please let me see options. Option A, rotate with same speed, no. Option B, rotate with dangerous high speed, yes. Option B is correct. Option C, rotate with reduced speed, no. Would come to stop, no. Generally motor will come to stop if there is no armature current entering into the motor. Suppose armature current is there, it is entering in, current is there entering in armature, means definitely motor will not stop. But here, yes, currently, armature current is not open circuited here, so motor will not come to stop. So to be frank, if field winding is open circuited, your flux becomes zero. So flux becomes zero here, so N becomes infinite. It runs with dangerously high speed. Your option is B. Option B is the answer for this question. Let us see. A D shunt motor running at rated speed. Now what is asking, if the shunt field winding is short circuited. So guys, try to understand what he's saying. He's saying that if the shunt field winding is short circuited. Okay. So do one thing. For this question I'm saying, if shunt field winding is short circuit means here shunt field winding. So let me provide a short wire. Short circuit means across the shunt field winding I had to keep a wire here. So let me take a shunt. I just kept a wire. So if shunt field winding short circuited, so I just kept one wire across shunt field winding, across field winding. This wire is having a zero resistance value. So now let us see. So guys, try to understand. Suppose this wire is having a zero resistance value. So everybody knows that current always flows through low resistance path. So now IL is coming like this. So let it will see. So here low resistance path is there, zero resistance, and here some resistance is there. For armature winding, some resistance will be there. Everybody knows that current always flows through low resistance path. So it will take path like this. It will take path like this. Okay, it is coming like this. It is entering. It is taking path with the short wire, and it's completing a loop like this. Okay guys, so tell me, in this case, do you have any current entering into the armature? No. So what will happen if there is no current entering into the armature? So what will happen? So if the shunt field winding is short circuited, then the motor will stop. Simply answer, motor will stop. Now suppose if the armature winding is open circuited, so answer to this question. So I'm asking now, if the armature is the open circuit. So please try to answer this question. What will happen if armature is open circuited? So easily I think you can answer this question. How? If armature is winding is open circuited, tell me, do you have any current entering into the armature? No. So let me show IL value. So I'm saying armature winding is open circuit. It's an open circuit, right? If it is armature winding is open circuited for this second question. So tell me, what about IA value equals 0? Whenever IA is equal to 0, so then the motor will stop once again. Motor will stop. Now what about answer to question number 3? If the armature winding is short circuited, okay? So tell me answer to this question. For third question. So once again, guys, let us see. Yes, he's saying that armature winding is short circuited. So let me keep a short wire across your armature. There is a meaning. If the armature winding short circuit means you have to keep a zero resistance wire across your armature winding. Now let us see. So current is coming like this. So always everybody knows that current flows to low resistance value. So this wire is having zero resistance. It is coming like this. Yes, it will take path like this. It will take path like this. So yes, it will complete path like this. Okay. So tell me, in this case, do you have any current entering into the armature winding? No. Once again, motor will stop. Very simple answers for these questions. Okay. Right. This is about your shunt motor. I given 1, 2, 3, and here 4. 4 questions are given. Okay. Let us see. A DC shunt generator is there supplying the power to DC bus bar. So in DC machine, always you are placing armature winding and the rotor. So let us assume that initially it is acting as generator. Okay. So please try to follow from starting itself. So otherwise we'll be having some confusions. Okay. Let us see. Yeah. So initially it is acting as what I said. It is acting as what? It is acting as generator. Okay. Yeah. In generator, DC machine, you are placing armature winding in the rotor, field winding and the stator. Okay. Now let us see. Let me take armature terminals also. A, field winding terminals F. Okay. So I can say RS, shunt field resistance. Okay. Initially, it is acting as a generator. Now everybody knows that if it is acting as generator, so current one more thing. So generator means you have to give mechanical input, no? So in the form of a prime mover torque, I'll be giving mechanical input. So TPM. I'm assuming this TPM direction. Let TPM direction. I'm assuming let TPM direction. I'm assuming in which direction? TPM in clockwise direction. Is the assumption. Let TPM in clockwise direction. Okay, guys. Now let us see. Because in interaction, current IA will be like this. It will be starting from A terminal. It will divide as ISH and IL. Here IL means what I can say, load current, right? Load current. And one thing you have to understand. So in generator, I told you, please try to refer simple loop diagrams if those are having doubts. In a generator, motor action will take place. Okay, in generator, motor action will take place. Because of motor action, electromagnetic will come into picture. Electromagnetic will be produced. That electromagnetic will be opposite to prime mover torque. So please try to understand. In generator, motor action will take place. Because of motor action, electromagnetic will come into picture. This is what I can say, electromagnetic torque. Direction of electromagnetic torque will be opposite to the direction of prime mover torque. I assume a direction of prime mover torque in clockwise direction. So your electromagnetic torque becomes what I can say now? Anti-clockwise direction. So guys, please try to understand. This electromagnetic torque is what I can say. This electromagnetic torque is in a generator, due to motor action, okay. Yeah, in generator due to motor action, electromagnetic is produced. That will be opposite to TPM. And everybody knows that one simple logic, for generator action, I can say I can say for generator action among TPM and TM, we should be more in generator. TPM should be greater than TM. Then only I can say generator action will come into picture. So that means what is the meaning for that? When it is acting as DC shunt generator, rotor rotates in the direction of prime mover. That is, I can write here, that is, let me use a white color here, it's not visible. That is, in DC shunt generator, that is in DC shunt generator, rotor rotates in the direction of, TPM. That is which direction? What I'm assuming TPM in a clockwise. That is clockwise direction. That is clockwise the direction. Okay. That is clockwise direction. So if it is not visible, I'll write clearly. That is, I can say, clockwise direction. Okay, guys. So please try to understand. So so this is very important. If it is acting as DC shunt generator, rotor rotates in direction of TPM, or I can say clockwise direction. This is very important for point for us. Okay. Now what is asking? If the prime mover fails, then the machine will behave as. Guys, whenever prime mover fails, means whenever a mechanical input given to the generator is not there. That means whenever prime mover fails, that DC shunt generator now it is acting as what? DC shunt motor. Very simple. So try to understand, guys. Whenever prime mover fails, I'm saying whenever prime mover fails, your DC shunt generator will act as DC shunt motor. Okay, so that is okay. But before that, I need to say one thing here. This green color electrometer, what I said, in a generator, I'm saying, in a generator, because of motor action, whatever torque is produced, that torque I'm just calling it as TM. So please try to understand here one thing I want to write here. Yes, this TM is proportional to what? This TM is, I'm saying, proportional to what? Proportional to flux into IA. Okay, this TM proportional to what I can say, flux into IA. This flux is depending on what, guys? This flux is depending on this ISH. And this IA is depending on this IA. Okay. So though I'm just making it is a lengthy, but try to understand so that you can understand easily, so that you can you can solve the remaining questions also easily. Okay. Yes, in generator, this pi is correspond to this ISH. Whenever IS direction is like this, though I had taken this pi like this. So whenever I is upward direction, you can take this IA, okay? So or if you want, I can show color also. Let me use same color here, IA value. And here also, let me take ISH. Okay. Now, so I took TM in an anti-clockwise direction for correspond to this direction of ISH, this direction of IA. Now what I am saying, if in generator in DC shunt generator, if prime mover fails, it is acting as a motor. In motor, because of motor action, electrometer will come into picture. So let me use this yellow color here, So now it is acting as motor. Motor means instead of giving supply to bus bar, it will take supply from bus bar. So IL direction will be like this, IA direction will be like this, ISH will be like this. Now guys, please try to tell me TM in motor. TM propose what? This TM is what I can say. This TM is when prime mover fails. DC shunt generator acts as DC shunt motor. This electrometer is due to motor action. when prime mover fails, okay, when prime mover fails, okay, right, this is enough for us. Otherwise, let me write in different way. Yeah, so this sentence is not I mean, okay, is okay, sentence correct only, but I'll write in an easy way. Let us see. This electromagnetic is, I can write like this. This electromagnetic is, this Tm is due to motor action, when prime mover fails, when prime mover fails in a DC shunt generator, is better. Okay, this is due to motor action, when prime mover fails in DC shunt generator. Okay, guys, tell me this Tm proportional to what? I can say flux into Ia. Try to understand. This pi is corresponding to, I can say, this ISH. This Ia is corresponding to, I can say, this Ia. Okay. So tell me, if you took this pi in, I mean, whenever I is from right to left, this arrow mark, after I took a pi like this, okay? And now I think there is no change in ISH. There is no change in green color ISH and yellow color ISH. So let me take a Tm proportional to, I'll take pi means pi only as it is, I'll take. Previously pi, now also pi only. And what about Ia? Previously Ia is upwards. Okay, this Ia mean I upwards when it is acting as generator. When it is acting as motor, Ia is downwards. So please guys, previously when it is upwards, I took positive here. Now it is downwards. Let me take minus Ia. So obviously your torque becomes negative. Previously torque is, I mean, whenever T proportional to pi into Ia, so if plus if pi is positive, Ia is positive, I took electromagnetic torque also positive here. Okay, positive means I assumed in anti-clockwise direction here. Okay, now whenever negative you are getting, so now tell me what the direction of your electromagnetic torque due to motor action. When prime mover fails, it will be in clockwise direction. So guys, so tell me, this is what I can say. Yes, so it is this Tm is the this Tm is opposite to this Tm. Okay, it is anti-clockwise. Now it becomes clockwise, simple. So Tm, I can say clockwise. So now your answer. So no doubt when prime mover fails, machine behaves as shunt motor. So option A is wrong here. Okay, option B or option C is your answer. So now my question is shunt motor. Okay, rotate in which direction? That's my question. So many people are confusing here. So they are comparing this yellow color electromagnetic torque with green color electromagnetic torque. That is wrong. Why? Initially it is acting as generator here. Initially it is acting generator. So generator rotates in the direction of what? Prime mover torque, right? Clockwise. Okay, so you have to compare this electromagnetic yellow color electromagnetic torque with TPM, not with this green color electromagnetic torque. Right to understand? If it is acting as generator, so then in generator rotor rotates in the direction of TPM, that is a clockwise direction. Or example, so now whenever I can say prime mover fails, it is acting as motor now. Now in this case, your electromagnetic is clockwise direction. So previously TPM also clockwise direction. Now whenever generator prime mover fails, it is acting as motor. In this case also TPM is clockwise direction only. So answer what? Shunt motor, no doubt, rotate in the same direction. So don't go for option shunt motor rotate in opposite direction. Your option C is wrong. Shunt motor rotate in the same direction. Option B is correct. So obviously machine will come to stop. It's not correct. Option D is also wrong. So guys, what is your right answer? Option B is your right answer. Shunt motor rotate in the same direction. That means you have to compare electromagnetic torque due to motor action when prime mover fails with TPM, not with this TM. In generator, whatever the in generator due to motor action, whatever the electromagnetic I got, don't compare this yellow color torque with this green color torque. So for getting answer, this yellow color torque should be compared with the TPM, not with the green color electromagnetic torque. Whatever the torque I got be in generator due to motor action. Okay, guys, you have to compare yellow color, I can say electromagnetic with the TPM. Now your answer is what? Rotates in same direction. So option B is right answer for your question. Okay. Now let me go for another question. It's a DC series motor is running at rated speed. Okay, rated speed. The field line is open circuited. So very simple. So let me take a DC series motor. So like series field winding is there. it is connected in series armature or in series with the supply. So I can write V here. So generally it's IL value, it's ISC, okay, it's nothing but RSC value, it's IA value. So now tell me, when a series mode running at, initially running at rate speed. Now my question is, if the field one is open circuited, so please tell me answer. So I think everybody can tell answer. The field winding is open circuit means, guys, so do you have any current entering into the armature winding? See, your field winding is connected in series armature. Whenever field winding is open circuited, so what will happen to your IA value? 0. Whenever IA is 0, what will happen to motor will stop. Simple. Next, if the series field winding is short circuited, so let us answer to this question. Yes. If the series field winding short circuited, now tell me answer. It is short circuit means let me provide a short wire across the series field winding. Now tell me answer to my question. So whatever current is coming here, it will this ISC will not enter now in this series field winding. It will take bypass through this short wire, and once again it is diverting into your armature. So it will take path like this. So guys, now tell me, whenever field winding is a short circuited, so no doubt, current, though it is diverting across a short wire, ultimately current is entering into armature now. So obviously motor will stop. Motor will start. Sorry, motor will start. It will not stop. But my question is, so motor will run with the what speed? Increased speed or reduced speed? That is my question. N proportional to EB by pi. Here, whenever series field winding is short circuited, so there is no current through field winding. There is no current through series field winding. So flux becomes, I can say what? 0. Flux is reduced here. To be frank, if series field winding is short circuited, so there is no current flowing through your series field winding. So flux becomes 0. So whenever flux becomes 0, what will happen to speed will be increasing. I mean, whenever flux is reducing, speed is increasing. Okay, so please, so then the motor will run with dangerously high speed. Dangerously high speed. Motor will run with a dangerously high speed. Because whenever flux becomes 0, there is no current through field winding. No. Whenever flux becomes 0 here, what will happen to your N value? It becomes infinite. No? So obviously, motor will run with a dangerous high speed. So what about third question? If the armature winding is short circuit. Now please tell me answer to this question. If the armature winding is short circuited, so tell me answer. So please try to answer this question. Yeah, I'm asking a very simple question. Please try to think and tell me. Right. Okay. Let us see. Yeah, this is what I guess armature. Okay, now please tell me answer to this question. So here plus minus V. Okay. Now what is asking? If the armature winding is short circuited. So very simple. So let me provide a short wire across armature. Now let us see. Current is coming like this. It will take path with the short wire, and it is taking return path like this. Do you have any current entering into the armature here? No. Whenever there is no current entering into the armature winding, so obviously what will happen to motor? Motor will stop. Motor will stop. Okay, guys. So this is what I can say. Okay. Now let us see next problem. A series generator supplying the power to DC bus bar. So initially, so those who are not able to see this red color, please try to see. I'm just studying here. A series generator supplying the power to DC bus bar. Initially, it is acting as a DC series generator. It is giving supply to bus bar. Let us see. So we having the series field winding resistance RSC. So here, yes, IA is like this one, and ISC is this one, and IL is like this. Okay. So the series generator supplying power to DC bus bar. Yes, supply is going to DC bus bar. Now please tell me. So same, whatever the question I explained this one for shuttle generator, the same question I'm asking for series generator. Please try to respond. So I think let us assume that initially in generator we are giving mechanical input in the form of prime mover. I'm assuming once again let direction of TPM in clockwise direction. Okay. And I tell you one more thing also, in generator, because of motor action, electrometric will come into picture. Let me take this electrometric like this. This Tm is what I can say. This Tm is in a generator due to motor action. In generator due to motor action, whatever the torque you got, that torque can be called as electrometric. Okay. To be frank, this Tm is proportional to, yeah, I told you one more thing. How can you write Tm opposite to TPM? I already wrote here in generator. Okay, in generator, motor action will take place. I'll get electrometer. Direction of electrometer and the prime motor will be opposite. This I'll explain simple loop diagram. Those who are having doubt, you can refer that. Okay. So if it is clockwise, it becomes what, guys? Anti-clockwise. Anti-clockwise. You know, Tm proportional what I can say generally pi into I, pi into I. This pi is corresponding to this direction of ISC. I can say ISC I can write. Okay, and this IA is corresponding to this IA. Okay, yeah. So if it is, if I take this ISC up, if whenever IS is upwards, if I take pi as a positive, if I take whenever I is upwards, if I take IA as a positive, you are at, I mean TM, I'm just taking it as a positive here. So positive means anti-clockwise in our assumption. Okay. Now, very simple question I'm asking. If it is actually whenever prime or fails, see, he asked me, when if prime or fails, then the machine will behave as very simple. When prime or fails, instead of giving supply to bus bar, it will take supply from bus bar. IL will be like this, ISC will be like this, and IA also, it will be also downwards. Here space is not there. So let me show ISC here, and IA I'll show here. Okay, guys. So yes. Yes, ISC and IA will be reversing. See, here ISC is coming downwards, previous IA is upwards, and IA is coming downwards, previous IA is upwards. So, guys, please try to understand this TM proportional to pi into IA. What is this TM? TM is what I can say when, I mean, this TM is due to same point, whatever I wrote here, this I'm writing here. Due to motor action when prime mover fails in DC series generator, same thing I'm writing here. Due to motor action, when prime mover fails in a DC series generator. Okay. So guys, your pi is becoming negative because previously IS is upwards, now IS is downwards, so it becomes pi becomes a negative, and IA previous upwards, now it is downwards, so once again it becomes negative. So torque once again becomes positive only. Previously TM is positive, at the time I took anti-clockwise. Now also I'm getting inside once again. See, very simple. Here both pi and I are reversing. So obviously torque will be in the same direction. Direction of torque which is due to motor action when prime mover fails is in the same direction as that of torque in generator due to motor action. This blue color electrometer and green color electrometer will be same direction. Previously I took it anti-clockwise. Now also it will be in anti-clockwise direction only. But while telling answer, you have to compare blue color electrometer direction with the prime motor direction. No, because initially this is generator. In generator among TPM and TEM. So I told you already in generator because of motor action electrometer will come into picture. That one I wrote here TEM. Among TPM TM, which should be more for having a generator action TPM. So here generator is in generator, rotor rotates in a clockwise direction. So that is what our reference direction. Okay. Now fails, it is acting as this series motor and rotation is anti-clockwise direction. Okay, previously it is a clockwise, TPM clockwise. Now TM is anti-clockwise. So please tell me now answer. So the series motor, no doubt, rotate in a opposite direction. Okay, opposite direction. Okay, guys. So series motor rotate opposite direction. Why I'm writing opposite means you have to compare this blue color electrometer with TPM because reference is generator. Okay, reference is TPM. Okay, you have to compare blue color electrometer with the TPM. Okay, so TPM is clockwise. This blue color electrometer is anti-clockwise. So anti-clockwise, clockwise. So obviously, rotate in the opposite direction. So option B is answer. Okay, right. Now let us see question regarding cumulative compound motor. So let us see. So cumulative compound motor may be long shunt or maybe short shunt. So let me take example. Let me take short shunt. Okay, it's your wish. You can take anyone. I taken short shunt here. So short shunt means your field winding will be like this. In a short shunt compound motor, okay, compound motor, your series field winding is connected in series with, I can say, supply. You can say plus minus V here. Direction of IL will be like this. ISC, RSC, series field variations, and it will divide as ISH and IA resistance value, RSH value. Okay, let us see. So guys, one thing you have to understand for answering this question, I told you in cumulative compound or I can say compound machine, you'll be having both shunt flux and series flux. Shunt flux and series flux will be there. Okay. Do you remember? I told you among 100% shunt flux contribution is only, it's around 80%, whereas series flux contribution is only 20%. So this one you have to remember. So which one is more dominant here? Your shunt flux is more dominant. Okay. That you have to remember for understanding some questions. Okay. Let us see. Initial n proportional to EB by pi. You know, cumulative compound means in place of pi, what I should write? Pi SH plus pi SC I should write here. Okay. And what is asking? If the series field winding is open circuited. So tell me what is your answer? So if the series field winding is open circuited, tell me what is your answer? It's a very simple question I'm asking. Let us see. Yes. If the series field is open circuited, guys, if there is no current, if you open circuit means definitely there is no current coming here. So to be frank, there is no current entering into the armature winding. So whenever series field winding is open circuited, so obviously there is no current entering into the armature, no. So obviously your motor will stop. Simple. Next, if the series field winding is short circuited, so guys, try to understand. Short circuit means very simple here. Short circuit means, yes, let me provide some short wire across series field winding like this. Okay, so current is coming like this. So because of this short wire, it will take bypass like this. It will take path through this short wire, and once again it's coming like this. It is dividing as ISH and IA. That means now, yeah, no doubt IA current is entering the armature winding. So no doubt motor will not stop. But question is, it will run. But my question, it will run with reduced speed, increased speed, or dangerously high speed. So guys, if there is no current flowing through series field winding, so obviously series flux becomes zero, no? Zero. That means your denominator value will reduce. Do you agree? Denominator value will reduce, no? Yes, it will reduce. So whenever it will reduce, previously pi s plus pi s, now only pi s because pi s is zero. Now n will increase. So don't say dangerous high speed. So it's increased speed only. What is the reason? Your pi s value, how much I told? 20% only. Only 20% flux only becomes zero here. Remaining 80% flux is there, no? Yes or no? Therefore, only 20% flux becoming zero here. So denominator is reducing. Your n is increasing. N is increasing. So I can write here, the series field winding is short circuited, then the motor will run with what I can say, increased speed. Okay. Suppose if I ask question like this, if the shunt field winding is open circuit, at that time answer please, guys. Same question I'm asking for shunt field. If shunt field winding is open circuit, okay. So please tell me what will happen if shunt field winding is open circuited. So please tell me answer now. I think now by this time only you might have understood. Please tell me answer. I am not shorting your series field winding now in this third question. I am providing, I'm sorry, previous second question series field winding is short circuit, okay. So at that time flux value pi s is 0. I told you denominator is reducing, n is increasing. Yes, it is running with motor run with the increased speed, that is okay. Now my question, third question is, if the shunt field winding is open circuited, if shunt field winding is open circuited, so tell me if it is open circuited, so what about no current is coming like this, current is entering into armature, no doubt in that. So let me use laser point if it is not visible. Yes, it is, current is coming like this. Though it is open circuit means though there is no current through shunt field winding, but current is entering into armature winding, no? Okay. So motor will start, motor will run. There is no problem. Okay, motor will not stop, it will run. But my question is with what speed? Reduce speed, increase speed, dangerous high speed. So here if shunt field is open circuited, guys, ISH becomes 0. Whenever ISH becomes 0, what will happen to pi SH value? So your pi SH becomes 0. That means 80% of flux is becoming 0. 80% of flux becoming zero means almost all, so it is very large amount of flux is reducing. So speed is very large. To be frank, I can say it will run with dangerously high speed. Okay. So I can write then the motor will run with dangerously high speed. Okay. Right. Next. Last question. If the shunt field winding is short circuited, so tell me answer. So please think and tell me. In the meanwhile, I can erase all those things. Okay. So please think and tell me what will happen if shunt field winding is short circuited. Okay. So guys, very simple thing only. Yeah. If shunt field winding is short circuited here, so whatever current is coming like this. So I told you current always pass the low resistance. So here short wire is having zero resistance value. It will take path through the short wire. Yes. Now it is taking path like this. There is no current entering into the armature. IA becomes zero in this case. Yes or no? Current always passes through low resistance value. No. So whenever shunt field winding is short circuited, current takes path through the short wire which is short circuited across shunt field winding. There is no current entering into the armature winding. So obviously whenever IA becomes zero, whenever there is no current entering into the armature, so obviously motor will stop. Simple. Okay. This is about regarding cumulative compound motor. So let us see last question. A belt driven, I think this last was right. Yeah. A belt driven cumulative compound generator supply power to DC bus bar. If belt breaks, then the machine will behave as. So please, I'll draw cumulative compound generator. In the meanwhile, you can try. Please don't waste your time. So let us please try. If you try, after trying, if you are getting wrong answers, nothing, no problem. But you have to practice. Okay, it's very important. Okay. So cumulative compound generator. No, let me take example long or short, your wish. Let me take a short shunt here. Short shunt means yes, shunt field winding across armature, and here the series field winding. Initially, it is a cumulative compound generator, so it is giving supply to bus bar. Let me take plus minus here. It is giving supply to bus bar like this. Okay. As usual, I told you it's nothing but RSH value and RSC value. I told you guys, if it is acting as the cumulative compound generator, you tell me in cumulative compound generator, your total flux equals to what I can say pi SH plus pi S, pi S plus pi SC. And one more thing, armature winding is placed in the rotor. Yes, I'm assuming direction of TPM. If it is generator means we have to give mechanical input in the form of prime mover torque. So let direction of TPM, prime mover torque, I'm assuming in a clockwise direction here. Okay. And because the direction EMF will be induced here, so IA direction will be upwards. It's generator, no, it is giving supply. Okay, current will be coming from the armature, it is going to the bus bar. So ISH will be like this, and ISC, I can say ISIL will be like this. Okay. Don't forget, I told you one more thing. In a generator, motor action will take place. Because of motor action, whatever torque I'll get, electromagnetic torque, that will be opposite to your prime mover torque. So by this time, I told you so many times. Those who are in doubt, you can refer simple loop diagram. Okay. This TM is due to what I get? This TM is in a generator. Due to motor action. Okay, due to motor action. In fact, this Tm is proportional to pi into Ia. This pi is corresponding to, I can say, you make it one out. Sir, pi means in a cumulative compound machine, is it pi S or pi SC? I told you guys, pi S is only 80%. Pi S is only, 20%. Okay, it's 80%, it's 20%. So in this formula, to be frank, you should take more dominant value, not less dominated. Among pi x and pi s, which is more dominating here? Pi s is more dominant because 80%, no. So please approximately I should take here pi sh. So guys, this pi sh is corresponding to this ish, this ish. Okay. and this IA is corresponding to this IA. Okay, now is it okay for you? Now, if TPM is a clock, I mean, in generated due to motor action, whatever torque produced, that torque I took in, anti-clockwise direction. Okay. Now, what I'm asking here, if a belt breaks, then machine will behave as this. Once again, it's a simple question, guys. If belt breaks, your generator acts as motor now. So if it is a motor, means IL will be in like this, ISC will be like this, ISH will be like this, and IA will be like this. Okay, guys, try to understand. Now, if a belt breaks, generator acts as motor. Everybody knows that it's a motor only. But my question is here, it's a cumulative compound motor or differential compound motor. That's what I need to discuss here. I need to decide. Okay. So guys, in a motor case, please try to see this blue color. If you want total flux, so initially IS is right to left. Now also it is acting as motor. Also ISH is from right to left only. That means there is no change in ISH value. Means your pi SH, I took here a positive here, I took here, now also I took a positive only, there is nothing wrong. And what about IST? If it is acting as generator, IST is from left to right with this arrow mark, and if it is acting as motor, IST is from right to left. So that means IST is reversing. So your plus pi SC becomes what I can write here, minus pi SC, very simple, minus pi SC. So pi equal to pi SH minus pi SC means, now tell me it's a differential machine or a cumulative compound machine. It's a differential compound machine, right? So obviously it's a motor. To be frank, it's a differential compound motor answer, differential compound motor. So if you see option A is wrong, option B is wrong, your option should be, it's a differential compound motor of either option C or option D should be your answer. Let us decide. So which one is the right answer? So it's a differential compound motor. Here is differential compound motor, but here question is rotate in which direction? So option C contains same direction. Option D is, let's see, it is saying that it is rotating in the opposite direction. Now you have to decide. So guys, try to see. I told you it is acting as differential compound motor. So TEM proportional to what? Pi into IA. I told you among pi SH and pi SC, which one is more dominated? 80% flux. Pi means shunt flux is more dominated. So please neglect pi SC for some time. Here you should take pi SH only, because if you take pi SC, your answer will become wrong. Please be careful. You should take more dominant value only. Since pi S 80%, should take pi SH only here. So now tell me, previously pi SH, I mean to say ISH is previous ISH, and now IS is same direction. So pi S becomes previous I took it as a positive value here. Now also I should take it as a positive value only. And what about IA? IA previous it is upwards, now IA is downwards. So previous IA I took it positive. Now I'll take IA value negative. So this becomes a negative and this becomes a positive only. Your torque becomes a negative. So here, whenever previously whatever the torque I took here is a positive here. So at that time, yes, whenever pi s is positive, IA is positive, your torque is also positive. Positive means I mean to say that anti-clockwise direction. Now this positive becomes what now? Negative. So now direction of electromagnetic torque when a belt breaks is which direction? It is a anti-clockwise, no? Positive means previous I took it anti-clockwise. Now it becomes what I can say clockwise. Okay, so obviously I can write here electrometer will be this one, this electrometer. Okay, so it is clockwise direction. So I can write here this electrometer is what? This electrometer is due to motor action, when prime mover fails in, I can say, cumulative compound generator. In a cumulative compound generator. Okay, so try to understand. So whether this TM is a clockwise or anti-clockwise, for designing that only I am using this torque which is produced generator due to motor action. Ultimately, if you want to tell the answer, you have to compare torque which is due to motor action when prime mover fails with the TPM, not with this TM. You have to compare blue color electrometer with the TPM, because I told you Initially, it is acting as cumulative compound generator. In generator, rotor rotates in the direction of TPM only. So you have to compare TEM with the TPM only. Then only you will get right answer. Some people are comparing TEM with this TEM. That is not correct, because if it is acting as generator, in generator, rotor rotates in the direction of TPM, not in the direction of TEM. Then why you are right? Why you are taking this for this TEM means whether this whenever prime mover fails, I'll get it is acting as motor. So because of motor action, I'll get electromagnetic torque. So if you want to if you want to know the direction of this electromagnetic torque, so for that I need one more electromagnetic torque. So which is equal to this prime motor. In generator, because of motor action, electromagnetic will come. So that electromagnetic will be opposite to this TPM. So for that only I'm just using this one. So after getting direction of your TM due to motor action when prime mover fails, you have to compare electromagnetic with the prime motor, not with this electromagnetic. In generator, due to motor action, whatever the torque I got, you should not compare with that torque. You have to compare torque due to motor action when prime mover fails. You have to compare that torque with the prime mover torque. Now answer please. TPM I got clockwise, and TM I got once again clockwise. So tell me answer. So what is your answer? So differential compound motor only rotates in the same direction. So option C is correct. Option D is wrong. Suppose some people, suppose if you take among pi SH and pi SC, I told you 80% flux is pi SH, so 80% flux is more dominated. Suppose that's why I'm neglecting pi SC. Suppose if you take pi SC is more dominated, that leads to wrong answer, because the people will think so ISH while I was taking pi S more dominated, this ISH is same, so there is no change in this pi. Here also positive pi SH, here also positive pi SH. But if you take pi SC, yes, previously IS is from left to right, now IS is from right to left. So you'll take a flux also negative here. Flux negative, IA negative becomes positive. So torque becomes the anti-clockwise direction. So then your answer becomes what here? Your electromagnetic will be anti-clockwise, TPM will be clockwise. Your answer will be option D. That is not correct, because among shunt flux and series flux, shunt flux is more dominated. It is because it is 80% flux, whereas series flux is only 20% flux. So please try to do in this way. You please try to give importance for shunt flux because it's more dominated, 80% flux. Then you'll get correct answer. Option C is correct answer for this question. Okay, guys. So right. Thank you. So this is for this session. Okay, we'll proceed in the next. In the next video, I'll be starting speed control of DC motor, which is very important for GATE examination, for IES examination, for PSUs also. So problematic point of view, if they want us some questions from DC machines, means maximum problems will be coming from speed control of DC motors only. That I'll discuss from the next video itself. Okay, right. Thank you.